When geologists and paleontologists try to sequence all of the events in our planet's history, it's obviously very difficult to do for a number of reasons. One of the reasons has to do with what you're seeing in this picture. Do you notice anything kind of interesting or odd going on here? Well, let me point out one thing. You see this layer here, this dark purplish rock? You notice how when it gets up here, it folds and comes down, and then it folds up again, and then it just stops. That's kind of strange that it just stops. Now there's another interesting thing here. Look at this layer above it. This layer here, this other dark stripe, comes up here, and then it stops when it hits this reddish rock. But we can almost imagine it coming up here and curving down, and it continues over here. And then it curves again, and it gets cut off, and it should come up here before it heads back down. What you're looking at here is called an unconformity or a nonconformity. What's happened basically is that some of these rocks are missing. This pink stripe should really come up here and come back down. If you're trying to figure out all of the events that have happened in Earth's history, it's kind of hard when you're missing rocks. Because if you're missing rocks, it means you're also missing fossils, you're missing volcanic ash, and you're missing other clues that we might use to figure out the complete picture of Earth's past. So let's take a look at how an unconformity would form. Okay, so we have strata, we have layers here. They're not horizontal anymore, but they would have started off horizontal. So at some point, this landscape would have subsided, it would have sunk under the water, sediments would have been deposited, and rock strata, or layers, would have formed underwater. Okay, the blue represents water. So just like most sedimentary rocks, this would have started underwater. Then some sort of crustal change would have happened. Maybe plates collided, and so you have pressure squeezing in, which caused either folding or faulting or tilting. Something happened, and these rocks got uplifted. They got pushed up out of the water. So that's what caused the folding in this picture we looked at. Then what would have happened is now that it's pushed up out of the water, weathering and erosion could have taken place. So wind or ice or maybe a mass movement, a landslide, or a stream or a river, something wore away the top of the folded layer, right? The top of this fold here is missing. The top of this fold is also missing. So some type of erosion, weathering and erosion took place. That's what created the missing piece here. Now, on top of this, we have more layers that are still somewhat horizontal. So we now know that something happened to form new layers on top of our fold. Well, new layers form underwater. So the whole area had to subside again, sink back down underwater, and deposition began again. So now we have new layers of sediment that got deposited. So those are the 4 steps that created this unconformity. Now, this picture I think is very, very cool. You can clearly see these layers, these folded layers that just stop, and then they continue, and then they fold again, and they fold again. But the top piece is missing. Let me go ahead and let me highlight that in case you're having any trouble seeing that. We'll use blue this time. So this white layer here should come up here, and then it comes back down, and it gets folded and folded again. The top is missing, and there's new sediment on top of it. Okay, so that's the unconformity, is actually this line. Let's draw it in. The actual unconformity is this line over here. Okay, so everything above there was formed after the bottom part. Unconformities tend to form when mountains are building, and periods of mountain building are called orogenies. And we're going to see that word on our reference table. When we look at our geologic timescale, we're going to see that a few times in the column here that shows us important events in New York. You're going to see things like the Alleghenian orogeny, the Acadian orogeny, the Taconian orogeny, the Grenville orogeny. These were all periods when these mountains were forming in our state. And they actually give you pictures of mountains to help you remember that an orogeny is a period of mountain building. So these unconformities form during orogenies, and what they represent are gaps in the rock record. There are rocks that are missing. They got weathered and eroded away. So there is a gap in the clues that we can find to tell us about the past. Here's another image. Can you find the unconformity? Can you find the gap in the rock record? Well, let's see. We've got layers here that are tilted, and then we have brown sediment or rock on top that's not tilted. So right over here is the unconformity. This is the gap. Whatever was up here, these tilted layers should continue. The side of them or the top of them got eroded away, and these new sediments were deposited above them. If we look at the Grand Canyon, we can see at least one unconformity. Take a minute, take a good look at this, see if you can find the unconformity. Well, the unconformity is going to be somewhere right over here, because these layers here are on a diagonal, and then they just end. And then above them, we have these horizontal layers. So there's an unconformity here. There's a gap in the rock record. This one's really easy to see, right? The rocks at the bottom are folded. You have some reddish ones and some white ones. And the folds just stop when they get up to this line right here. That's the unconformity. That blue line represents a gap in the rock record. And then these other sediments were deposited on top. This picture I think is really cool too, right? So you have these bottom layers that are tilting up, which just stop when they get up to this point. So in this picture, the unconformity, I'm going to go over it in red. This line right here is the unconformity. So these bottom layers got weathered and eroded, they got cut off, and then new sediment formed on top of them. Okay. Now there's another name for these unconformities, and again, they're also called nonconformities. But because they represent a gap in the rock record, and because they formed when rocks got eroded and then buried underground, we also call them buried erosional surfaces. So this red line, this unconformity, represents an erosional surface that then got buried underneath other sediments. So we'll be looking at a lot of unconformities over the next few days. If you have any questions about them, please don't hesitate to come in and ask me. But I think the more of this that we look at, the more that we do, you're going to get this, and it will make sense hopefully sooner rather than later. Thanks for watching.